guys, today's video is on functions. We're going to get through this page pretty quickly, not too bad of a material, and then maybe we'll get to something else called evaluating functions. So what is a function? It is a type of relation that doesn't repeat x values, or another word for x values is called domains. We're going to test to see whether things are functions, whether relations are functions. We can test them through if we're given ordered pairs. We can test them if we're given graphs. Pretty easy to tell whether something's a function or not. Again, it cannot repeat x values. So let's look at number 1. Here's all the x values. Is there a number repeated? It's not, nothing's repeated. So yes, this could be a function. This is a function. Number 2, is there any numbers that's repeated? Yes. Here. So no, this is not a function. You can even look at a table and identify whether a relation is a function. Let's look at number 5. So are there any repeats here? Yes. There's repeats. So you'd say no, not a function. We can also look at mapping to see if something's a function or not. Number 9. So we have -3, 0. We have -1, 4. We have 2, 7, and 4, 4. There were no repeats. So yes, this is fine. However, in number 10, you see there is a repeat. We have -4, 4. We have -1, 0, but also we have -1, 7. So it looks like this, -1, 0, and then -1, 7. So there was a repeat with the -1. You can also see that by the arrow, that there's an arrow going from -1 in 2 directions from the domain. So no, this is not a function. Another way we can test functions is through a graph. We do what's called the vertical line test. What we can do is look on a graph and take a vertical line, and see whether the graph crosses through twice. Here, that's fine, it only crossed through 1 dot. Here, that's fine, it crossed through 1 dot. However, here, if we draw a vertical line, you can see that it crosses through 2 dots. And if it does that at any point throughout the graph, it's not a function. It fails. It fails the vertical line test. Number 12, that's fine. It only crossed through once. That's fine. It only crossed through 1 dot. That's fine. Only 1 dot. And then here, it only crossed through 1 dot. So that's totally fine. Yes, it is a function. You can also look at graphs that have lines. Here, let's draw a vertical line. We can draw it anywhere. We can draw it here. We can draw it here. We can draw it here. But you can see that no matter where we draw the line, it's going to cross through the graph twice. Here, it crosses through the graph there. It crosses through the graph there. So even if it crosses through more than one time, it's not going to be a function. It failed. So here's just one example where this graph fails. We can test this one. Here, it only crossed through 1 time. Even here, it only crossed through 1 time. And if we keep drawing lines throughout, it's only going to cross through 1 time. There's not going to be a time where we draw a vertical line and it crosses through more than 1 time. So we say, yes, this is fine. It is a function. And then the last one, if we draw vertical lines throughout the graph, there is not a point where it crossed through more than once. So all of these just crosses through once. So we would also say, yes, it's fine. This is a function. Write down what questions you have on telling whether dots or graphs or tables or mappings are functions or not functions. I'm going to go over some function notation real quick. I know this page is not with you. What you can do is either print this off or look on Schoology. It's on there. It's called notes function eval. Please look at that. If not, you can write on a separate sheet of paper or just pay attention and then fill these in class. I want to start this so we don't have as much to do next class. So function notation is taking an equation written y equals, for example, we have y equals 2x minus 8, and we can rewrite y as we write it f parenthesis x and then the 2x minus 8. Instead of y, let me write a better f parenthesis x, and we read this as f of x. That's how mathematicians say it. So instead of y, we can replace it with f of x. Let's look at some examples where we use f of x or g of x. All we're going to be doing for this topic is substituting. We're going to substitute in for x. Looking at number 1, we have f of x equals x plus 7. Part A says, find f of 5. So instead of x, we're going to put 5. So it's going to be 5 plus 7, which is 12. We can do the same thing for B. Find f of negative 1. Instead of x, we're going to put in negative 1. So all we're doing with this stuff is substituting in the number in parentheses in for x. And then C would be negative 3 plus 7, which is 4. Let's do a more complicated example. Let's do number 4. In number 4, we're going to take whatever's inside the parenthesis and we're going to put it in for x. But if there's multiple x's, you're going to put it in for both x's. Negative 4, and remember, whenever you put a number in for a variable, use parentheses, and then follow the rules of GEMDAS. Negative 4 squared is 16, minus negative 4 makes a plus 4, so we're left with 20. Let's do another one here. Let's take negative 1 and plug it in for x into both x's. Remember, use parentheses when substituting. Negative 1 squared is 1, minus a negative 1 makes plus 1, so that simplifies to 2. Let's do another one. Let's move down. Number 5. Let's put in negative 4 in for x. So it's going to look like 3. Instead of x, we're going to put negative 4 squared plus 7. Don't forget to do the exponent first. So we have 3 times 16 plus 7. Then do the multiplication. 3 times 16 is 48. Plus 7 gives us 55. So again, all we're doing is taking the number in parentheses and putting it in for x, and then solving using GEMDAS. A couple other weird types of evaluating expressions that we'll talk about in class, but this is the general rules of this topic. Let me know what questions you have before we do some more practice in class tomorrow. Have a great night.